Okay, so today we are talking about 4.1c, continuing with our trig. We will be doing trig for quite some time, but today is the last lesson of 4.1, so it's 4.1c. We've already done coterminal and terminal by now, but now what is they gave us a coterminal and a degree in radians. So let's say our degree, our theta, is pi over 3. And we want to find our coterminal angles. Well, I want to draw a picture to see what that really means when I have pi over 3. First, it's a positive degree because it's a positive number. So I know that the angle is going to move in a counterclockwise position. So I'm going to continue to counterclockwise. I remind myself that, okay, so this is 0 when you talk about radians. 90 degrees, just to give me an idea, if you don't remember, 90 degrees, I know that 100 degrees is pi, right? So 90 degrees is pi over 2, and this is pi over 3. So this is like a third. It's going to be less than a half. So it's somewhere here. It's going to be somewhere here. It's moving in the positive direction. So moving positive direction. This is my pi over 3 in the positive direction here. So now I just got to find the coterminals. Well, I'm going to first find the positive one, right? So the positive one, I'm going to go up to it, but it already hit it. So I'm going to go around once and then hit it again. Bam. I know that my positive, the entire 360 degree, by this time, you should kind of remember that. 360 degree is 2 pi. So to get my first one, I'm just going to add 2 pi to pi over 3 for my first coterminal in the positive direction. So 2 pi, I'm going to convert that into multiply it by 6. So multiply it by 3. So 6 pi over 3 plus pi over 3. That gives me 7 pi over 3 for one of my coterminals. Next, I'm going to focus on, let me get a different color here. Let's work with red. I'm going to focus on the negative direction. So I'm going to go clockwise. So I'm going to start here at my 0. And I'm going to go, okay, I want to go all the way around and I want to hit the angle. There we go. That is my negative coterminal in terms of radians. I know I'm dealing, but I want to ignore where it is. So let's imagine I'm going to go here. If I go down, that would be going down negative 90 degrees, right, to this. So this would be my negative pi over 2. And then if I hit this line, this is actually negative pi because I'm going negative 180 degrees. This up here would be 270. So 3 halves pi, negative 3 halves pi, because this is 1 and 1/2, so negative 3 halves. Now I gotta go further on. So I gotta. This is one. This is 1/3, and now I just gotta find the difference between 1/3 and a half to find what the remainder that it goes. So if I take pi over 2 minus pi over 3, let me change that. Multiply both by to have 6. Yeah. So this multiplied by 3. So this is 3 pi over 2, and this is 2 pi. So this is actually a 6. So it moves the remainder of a negative 6. So I'm going to take negative 3 halves over 2 plus 1/6, or negative pi over 6. I'm going to convert the first one to be able to add that. Multiply both by 3, so this would be negative 9 pi over 6 minus pi over 6. That gives me negative 10 pi over 6, simplify that further, divide both the numerator and denominator by 2. That gives me negative 5 pi over 3. So this is my negative direction, and that is my positive direction using radians. Let's do an example now, continue on to complement and supplement. By now you should know what complement or supplement. Let's give an example here. We got 7 pi over 8, and you want to find the complement and supplement of 7 pi over 8. My brain kind of doesn't really work in radians, so if I try to get an idea of what 7 pi over 8 is in terms of degrees, right? I know that an entire pi is 180 degrees, so it's less than that by an eighth. It's less than that by an eighth. So if I drew a quick picture, it's somewhere here. It's somewhere there. So I know it has to be bigger than pi over 2, because pi over 2 is a half. 7/8 is way bigger than a half. So it's bigger than 90 degrees. Right there. So in terms of complements, it cannot have any. It's impossible. It's impossible to have any complements because it is way bigger than 90 degrees. But to get to 180 degrees, which is an entire pi, right? So if I multiply that by 8, that's 8 pi over 8. Subtract that, 7 pi over 8. That gives me pi over 8. You only need a pi over 8 in order to get to 180 degrees. So my supplement here is pi over 8. Now, what if they gave you the degree and they're using radians, but they gave you a number? They just give you a simple number. So let's say they want to find the degree and they give you the number 1. Right? They just give you the number 1. You're like, okay, what is that? Well, radians in itself is numbers, but normally we use pi in there. So I convert it all to the number. So if I actually punch it in, first I start out with 0. Pi over 2, if I punch that into my calculator, that is 1.57-ish. So I know my angle is somewhere between these two. So my angle is here. This is 1 in terms of radian. Now, if we want to find the complement, we just do the same. What I'm going to do is I'm going to take my pi over 2, or actually before I even punch it in, I'm going to do pi over 2 minus 1. I'm going to for my complement, so I'm going to actually punch it in pi over 2, pi divided by 2, subtract 1, and that gives me, in the calculator, that gives me 0.57, or I could do 1.57 minus 1. That's a 0.57. Now my supplement here is, now I'm just going to punch in 2 pi into my calculator. That gives me a, this is a pi. So pi, as everybody knows, that's 3.14. 3.14. So I just do 3.14 minus 1. That gives me a 2.14. In this case, this is 1.57 up here. So here is my complement, and here is my supplement if you were given just a number without any pi for your radians. Now let's convert our angle of degrees into radians without actually using our calculator whatsoever. So let's say we're given negative 70. Well, to convert that into radians, all I have to do is multiply by pi divide by 180, and that will give me my radians. Without using my calculator, what I can do is I can simplify. I can get rid of these zeros right away. 0, 0. This gives me a negative 7 pi over 18. And I cannot simplify that anymore. So my answer is 7 pi over 18 radians. Likewise, what if I need to convert my radians back into degrees? So let's say I have negative 7 pi over 6 radians and I want it in degrees. Well, then we just multiply by the reciprocal of that. So 180 over pi. That cancels out my pi. I'm going to simplify before I even multiply. I know 6 times 3 is 18. So 6 goes to 180 30 times. So it is just negative 7 times 30, which is negative 210 degrees for conversion without using any calculator. Simplify first, and then you don't need a calculator. Let's do a tricky one. Let's say we got one that probably isn't going to give us a nice number, right? You should have the math chops to do it now. So let's say I got negative 0.71 radians, and I need that to be into degrees. Well, you just got to trust your process. So negative 71, to get into degrees, remember we multiply by 180, divide by pi, will give me into degrees. So then I'm just gonna use my calculator now, because 0.71, negative 0.71 times 180, divide by pi, and I got negative 40.680 degree as my answer. Let's now do an example of how to convert an angle. Let's say that we're given an angle. Let's say 315.24 degree. And we want to convert that into degree, minutes, and seconds. Well, all I have to know is this is 315 degrees. This is already given. However, to get the minutes and the second, all I have to do is to take the 0.24 and multiply by 60. So 0.24 times 60 will give me my minutes. So 0.24 times 60, I get 14.4. So this is 14 minutes. 14 minutes. I take that 0.4, multiply that by 60, and that gives me 24 seconds. So this is 24 seconds right here, and that's how I would convert.